All right, so this is our next question from Cat23, the first lot. You can try it out, pause the video and resume the video for the solution. Okay, so very painful looking questions, and yes, lengthier than most of the questions in this particular slot. So I would call it a type C rather, this particular question. The problem with this is they're saying the equation x cube plus 2r plus 1 into x square plus 4r minus 1 into x plus 2 is 0 has minus 2 as one of the roots. If the other two roots are real, then the minimum possible non-negative integer value of r is. So given the condition that minus 2 is one of the roots, many people would jump into their spots and say, Array, we'll put minus 2 in place of x and it should satisfy the equation and probably we'll get the value of r. But that's the challenge. If you substitute x as minus 2 in this equation, guys, you're going to get minus 2 cube plus 2r plus 1 into minus 2 square plus 4r minus 1 into minus 2 plus 2 is equal to 0. So that makes it minus 8. 4 into 2r is like 8r and 4 into 1 is 4. 4r into minus 2 is minus 8r and minus 2 into minus 1 is like plus 2. Plus 2 is 0. Now if you observe carefully, guys, all the terms get cancelled out. 8r and minus 8r will give you a 0. 4 and 4 is 8 minus 8 is 0. Ultimately you get 0 is equal to 0. Nothing happening. So substituting the value of x as minus 2 does not give you any solution to the given equation. So what do we do in this case, guys? We use the fact that x is equal to minus 2 satisfies the given equation. So this entire equation can be simply written as x plus 2 into some other equation. Probably it's a cubic equation, so you'll be multiplying this with the quadratic, right? So let's try to find out this quadratic equation. Okay, this would help us, right? First step, we write this equation as x plus 2 into a quadratic, and now we divide this entire equation x cube plus 2r plus 1 into x square plus 4r minus 1 into x plus 2 with x plus 2. Okay, so you can use your regular division, okay, division of polynomials, but a slightly better way would be to use a synthetic division. Write the coefficients here. So x cube coefficient is 1, x square coefficient is 2r plus 1, x coefficient is 4r minus 1, the constant term is 2. So first step, we write all these coefficients and we will divide these coefficients by minus 2, which is the root. So normal synthetic division process, take the 1 below. 1 into minus 2 shall basically give you minus 2. 2r plus 1 minus 2 will make it 2r minus 1. 2r minus 1 into minus 2 shall make it 2 minus 4r. When you add this, you are going to land up with 4r, 4r cancel. 2 minus 1 will give you 1. 1 into minus 2 will give you minus 2. And 2 minus 2 gives you 0. Obviously, it has to be 0 because minus 2 is the root of the given expression. So the remaining values 1, 2r minus 1 and 1, they are the coefficients of the quadratic equation we are dealing with. So 1x square plus 2r minus 1 into x plus 1. This is the other quadratic expression that we need. Basically, this equation is of the type x plus 2 into x square plus 2r minus 1 into x plus 1. Okay, now we know that one root is obviously minus 2 as given in the question, but the other two roots should be real numbers. For that, the roots of this equation should be real, right? And now for any quadratic expression, the roots would be real when b square minus 4ac would be greater than or equal to 0. Right? So b here is 2r minus 1. If you compare minus 4 into a here is 1, the coefficient of x square, into the constant term here is 1. This should be greater than or equal to 0. So 2r minus 1 the whole square minus 4 should be greater than or equal to 0. And now this is like 2r minus 1 the whole square is greater than or equal to 4. Using our inequalities, we can say that 2r minus 1 would be less than or equal to minus 2, or 2r minus 1 would be greater than or equal to 2. So from here, if you solve this part, you will get 2r minus 1 is less than equal to minus 1 by 2, or 2r is less than equal to, add 1 to both sides, minus 1. You'll get the value of r as less than equal to minus 1 by 2. That's not happening because the question says want the minimum non-negative value of r. So this has to be ruled out. Next, the second possibility we have is 2r minus 1 is greater than equal to 2. So 2r is greater than equal to 3, adding 1 to both sides. We have got r is greater than equal to 3 by 2 or 1.5. Yes, this would work for us. If r is greater than equal to 3 by 2 or 1.5, the least positive integral value r can take is 2. And that's the answer to our question. The minimum possible non-negative integer value of r here will be equal to 2.